So let us discuss about slew rate in this video. So it is one of the important parameter of opamp. So it is defined as the maximum rate of change of an output voltage with respect to time. So it is usually specified in terms of a volt per microsecond. So ideally the slew rate value is infinity, okay, but since it is represented in volts per microsecond for the practical opamp, so it means the output rises or falls no faster than 1 volt every microsecond. Okay, so that is means 1 volt per microsecond. Okay, so usually for IC 741, okay, for this 741 the slew rate value is 0.5 volt per microsecond. So slew rate is equal to dV divided by dt. So it is rate of change of the voltage per with respect to the second. So this I can write it as I by C, because we know that I is equal to dq by dt, and q I can write it as C dV by dt, right? So what is this value of I? I represent as I max. This value is nothing but 15 microampere divided by 30 picofarad. So if I solve, I will get this is equal to 0.5 volt per microsecond. So this I is nothing but the current furnished by the internal circuit, and C is nothing but a compensation capacitor. So if I give V as equal to Vm sin omega t, if I substitute, if I want to find the value of slew rate, it is nothing but dV by dt, right? So if I differentiate this one, I will get Vm omega cos omega t, right? So for the maximum value of if I want to find the maximum rate of change, so dV by dt maximum is nothing but it will occur when cos omega t is equal to 1. So this is equal to Vm omega. So this omega I can write it as 2 pi f, okay. So Vm is nothing but a maximum value of the sine wave, right? Vm is nothing but a V peak. So if I want to find f is nothing but, this is nothing but slew rate, right? So slew rate divided by Vm into 2 pi. Yes. In other words, I can write this is in terms of volt per second, right? volt. Here Vm is nothing but voltage, and F is nothing but 1 by S. So if I want to get the answer in terms of volt per microsecond, I need to multiply this one by Vm 2 pi F divided by 10 power 6. Okay. So micro means it is 10 power minus 6. So these two get cancelled out. So you get the slew rate is equal to Vm 2 pi F divided by 10 power 6. This is your first equation. So the slew rate will happen only for the large signal. Okay, in terms of volts. Okay, so if the output voltage or the frequency is greater than the slew rate value, definitely there will be a if the output exceeded the slew rate value, it will result in distortion. Okay, so let me solve one problem based on this slew rate. So assume the slew rate is equal to 0.5 volt per microsecond. What is the maximum undistorted sine wave that can be obtained for 12 volt peak value, and second one is for 2 volt peak. Okay, so we know that what is the slew rate formula? Slew rate is equal to, from this equation, slew rate is equal to Vm 2 pi F divided by 10 power 6. Vm 2 pi F divided by 10 power 6. So this is nothing but 0.5 volt per microsecond, that is equal to Vm is, let me assume that is 12 volt, 12 into 2 pi F divided by 10 power 6. Okay, so if I want to find the value of F, F is nothing but 0.5 into 10 power 6 divided by 12 into 2 pi. So if I solve, I will get 6.63 kilohertz. So this must be my maximum operating frequency. So if the output exceed this frequency, this will result in the distorted output. Similarly, if I want to find it for this is for 12 volt and this is for 2 volt. So if I substitute 0.5 into 10 power 6 divided by 2 into 2 pi, I will get 39.8 kilohertz. So this is for 2 volt, right? So similarly, I can find it for so suppose in the problem they are given as they have given second problem, gain as 50 and operating frequency, maximum operating frequency as 20 kilohertz. Okay, 20 kilohertz. So if I want to get the undistorted output, what is my value of P out? Okay, so substitute in this formula. So slew rate is 0.5, right? 0.5 Vm they have given Vm, I don't know, a value of Vm into 2 pi f. Okay, 2 pi f value is 20 kilohertz divided by 10 power 6, right? So I can write Vm is equal to 0.5 into 10 power 6 divided by 2 pi into 20 kilohertz. So if I solve, I will get answer as 3.98 volt. So what is my V peak? V peak to peak. V peak to peak value is 2 into Vm, right? So that must be 2 into 3.98. That is nothing but 7.96 volt. So this is my input signal. My output signal value is so we know that V0 divided by VA is equal to A. Okay, so sorry, this is V0. So V0 value is 7.96 and A value is they have given us 50. So what is my VA value? VA is nothing but 159 micro volt. That is peak to peak value. So if my input signal is less than this value, greater than this value, there will be a possibility of distortion. Okay. So the slew rate limiting is depends on both the frequency and amplitude. Okay. So it often increases with the closed loop gain and power supply voltage.